Hello guys, mathematicians and scientists across the world, they always try to find some patterns so that they can understand the universe and this world in a more better way. So they like find the small dots and connect them, create a story to understand the beginning and the end of the story, how it's gonna be, how it is happening right now. So connecting the dots has always been like the basic strategy of any scientific discovery or process basically. So over here today we are going to connect some dots and understand another story behind it. It's a happy story because it has happy ending in it. Okay, so let me just start with the story over here. So for that, I'm not kidding, I am going to make some dots and I'm going to connect those dots for carrying on with the story and making you understand what the story is. So over here, these are the dots that I was talking about, and I am going to connect these dots and they will tell us a story, believe me. Let's just check them out. So we have a four-sided shape. If I consider these as straight lines, it's a four-sided shape or a four-sided polygon I've got. Now what this polygon has to do with the story? Okay, so the thing is, I'm gonna set some rules. So rule number one, I'm gonna place random dots. Okay, you can play it as a game as well. The rule number two, no three dots must be in straight line. Okay, these are the rules with which I'll be placing my dots. Okay, now so as I said, I will connect these dots, to make a polygon. Now I have started with a four-sided polygon over here. So as you can see that I have made four sides with 5 dots, but I could have easily made a pentagon as well, right? Not just this four-sided polygon. Well, according to a theory basically, so it says that we need to ensure that there are 5 dots on a sheet of paper, to ensure that we can actually create a four-sided convex polygon. Now there are few things. Four-sided is quite obvious to understand. It has 4 sides, the shape has 4 sides. The convex means whatever the polygon that we'll be creating, the interior angle of those polygons will always be less than 180 degrees. This angle is less than 180 degree, this angle is less than 180 degree, this is less than 180, and this is also less than 180, right? But you can question me that, well, I can create a four-sided polygon with 4 dots as well. Well, I'll give you an example. For example, like this one. If I connect the dots over here, what I get is not a convex four-sided polygon or a convex quadrilateral. It's a concave quadrilateral. Why? Because one of its angle is more than 180 degrees. So to ensure creation of convex quadrilateral, we need 5 dots, or I should say we need minimum 5 dots to ensure the creation of convex quadrilateral. Now I can place it anywhere if you want. For example, over here, just check out this particular method, like 1 2 3 4 and this is 5, right? So I can just leave this particular one and I can join this 4 dots, right? Or in a different way, I can make this quadrilateral like this. This is also four-sided. polygon, correct? So what it says, the theory says, is we need minimum number of 5 dots. Minimum 5 dots is required to make four-sided convex polygon. But is there a rule or theory for making a pentagon? Yes, there is. Is there a rule for making a hexagon as well? Yes, there is. Well, the thing is, this particular problem is known as happy ending problem. Why it is called happy ending problem? As I was saying, this problem has a happy ending, right? Okay, that's not the reason. Well, the reason is the mathematicians who were involved in solving this particular problem, they got married and they are still happily married. The name of the mathematicians are Esther Klein and George Schkeres. And as I said, that there is a theory, right? So according to that particular theory, we have a formula as well which says f of n is equal to 2 to the power n minus 2 plus 1. So I'll explain to you what it means. Here f of n means number of dots required to ensure creation of n-sided polygon. Let's check it out. If I put n is equal to 4, so I want to make convex quadrilateral. According to this particular formula, I'll have 2 to the power 4 minus 2 plus 1. That is 2 to the power 2, right? Which is 4 plus 1, 5. So I need minimum 5 dots, right? I think I should write minimum here, right? So now if you want to check out for a pentagon as well, you can just plug in the value 5 over here. So 5 minus 2 is 3, right? So 2 to the power 3 will give you 8, and 8 plus 1 is 9. So you need 9 dots to make a convex pentagon. Interesting, right? So although this particular formula works for our polygons, it's still not proved yet. The theory is still a theory, or I should say it's a conjecture. It's not a theorem. Conjecture means something which follows the law, something which follows the law, which follows the rule, but it's still not mathematically proved yet. So this particular conjecture, the happy ending problem, is also known as Arthos-Schkeres conjecture. Quite a famous one. If you are able to solve this one, there might be a chance for you to get a Fields Medal in mathematics. So as I said, I'll leave this up to you to connect more dots, find more stories, and understand the universe in more better way. So this is what we are going to discuss for today. I'll see you in the next amazing video. Bye.